first two problems on this set of notes are old problems we learned to do last week. Finding the length of CM. We see is the hypotenuse. Here's the opposite. Connecting the opposite side with the hypotenuse is the sine of an angle. So we use the sine equation. The variable ends up in the denominator. We cross multiply. We solve for x. You can pause the video if you need to catch up on these notes, but I think it would be worth filling these in if you need to. Second problem, again another familiar problem. I've asked you for the tangent of angle Q. That's the opposite over the adjacent. Here's angle Q. There's the opposite side. Here's the adjacent side. We simply write 12 over 5 and we're done. Number 3 is a new problem, one we haven't learned how to solve yet. We're trying to find the measure of angle E. The measure of an angle. Like how many degrees is it? We haven't used trigonometry to solve these kinds of problems yet. Here's angle E down here. And again, we notice that I've provided two of the three sides in this right triangle. We could use the Pythagorean theorem to find this other side if we wanted to, but that's really not going to get us closer to finding the measure of angle E. You might not know that unless you tried it, but I'm just trying to move through these notes quickly, and I can tell you that that won't get us any closer. What we want to do is, same thing we want to do in a problem like this, and that is identify from angle E's point of view, because that's the angle we're interested in, what side is this? It's the adjacent. And what side is this? It's the hypotenuse. What connects adjacent and hypotenuse? Cosine. So we want to write a cosine equation. Just like in problem number 1, we wrote a sine equation with the angle inside. We're going to write a cosine equation with the angle inside. Cosine of angle E equals the adjacent 41 over 75. Okay. Now in the other problems, we've actually had an angle measure and we put this in the calculator. But in this problem, we're looking for the angle measure. Okay. There's nothing on this side of the equation we can put in the calculator, but we could put this in the calculator if we wanted to get a decimal value. Turns out that actually can be very helpful. So we put that in the calculator, we'll get approximately, I'm going to round it to 4 decimal places, 0.5466. So somewhere there's an angle measure whose cosine turns out to be 0.5466. Now there's two ways we can solve this problem. We're looking for angle E. We're not finished. We're looking for a final answer that says angle E equals something. And right now, this equation doesn't say angle E equals. It says cosine of angle E equals. So we're not done. Okay? But here's what we do have available to us. We've learned how to use this table of trig values to look up decimal values from sines and cosines and tangents. What if we have the decimal value? We could look that up and go backwards and find the angle that it came from. We have to go to the cosine column. That's so important once again. So let's go to the cosine column right here and look for 0.5466. Well, I got to go way down this column. Actually, when I get to the bottom, it's still not there. So I'm going to have to go over to the next cosine column and keep working my way down. And what I find is that 0.5466 doesn't show up exactly, but it would be between 0.5446 and 0.5592. It would be right in between there. And so the angle that that cosine value came from must be somewhere between 56 and 57 degrees. So you can give me an answer 56 degrees or 57 degrees or anything in between. I will accept that. You want to tell me 56.5, that's fine. Okay? So that would be our answer. You could look it right up from the table. Angle E is approximately, let's say 57 degrees. 56 would have been fine. 56.5 would have been fine. But I also want to show you how to use your calculator to solve this problem and to get an even more precise answer. Maybe it is 56.5, maybe it's 56.7, maybe it's 56.8. What we need is a way to get rid of that cosine so that only angle E is left on this side of the equation. This is kind of like if we were writing out how to solve this equation, x squared is equal to 75. What do we write? We use the square root symbol, right? And then where do we put that square root symbol? We put it on the left side of the x squared, and we put it on the left side of the 75. Okay? It's important you understand that the square root symbol goes on the left side each time. That's different from, let's say we were solving this problem, x over 3 is equal to 12. What would you do? You would multiply each side by 3. Well, multiplication you can put out on the left over here and put it out on the right over there. That's fine, because the order of multiplication doesn't really matter. You can put it on the left or put it on the right. It's all okay. Not with a square root symbol. You would not write the solution to x squared equals 75 by doing this. You wouldn't put a square root symbol there and then a square root symbol there. That would look silly. That would look like you had never seen square root symbols before and didn't know how to use them. So when we're undoing cosine, we use this crazy looking symbol. It actually looks like a cosine to the negative first power, but when you see that, we read cosine inverse. Inverse, the word inverse is like the word opposite. And so cosine inverse is the opposite of cosine. Just like multiplication is the opposite of division and cancels it out. Right? Multiplication is the opposite of division and cancels it out. Square rooting is the opposite of squaring and cancels it out. Cosine inverse is the opposite of cosine, and it cancels it out, leaving just the angle E standing there. But if you learned anything in algebra at all, you learned that if you do something to one side of the equation, you better do it to the other. So we have to do cosine inverse over here of 0.5466. And if you've got a cosine button on your calculator, then you have a cosine inverse button on your calculator also. So find that cosine inverse button. On a graphing calculator, it's right above the cosine button. You need to hit the second key. Second and then cosine will get you cosine inverse. And punch in your 0.5466, close the parentheses, hit the enter key, and you're going to get 56.8 blah blah blah, a very precise answer. 1 decimal place is good enough for me. And so then you don't have to go to the table, and you don't have to worry about making sure you're in the correct column, which is such an easy mistake to make. The next 3 problems are just like these, but we're looking for angle measures. And number 4, let's complete this problem. I didn't even finish it. Let's find the measure of angle C. Okay, so from angle C's point of view, I've got the adjacent, I've got the hypotenuse. We need a cosine again to connect those. Cosine of angle C equals the adjacent, 50, over the hypotenuse, 61. 50 over 61 as a decimal is 0.8197 approximately. Cosine of angle C equals. Now again, you can go look this up in the table, or you can do cosine inverse of cosine of angle C, and cosine inverse of 0.8197. Cosine inverse is the opposite of the cosine and just leaves the angle C standing there. Cosine inverse 0.8197, your calculator will tell you that that is about 34.9 degrees. And so if you went looking for this decimal number in your table, you should find it somewhere between 34 and 35 degrees. You won't find that exact decimal, but you'll find 2 numbers really close to it, between 34 and 35 degrees. Number 5, looking for the measure of angle Q. Let's see, we have the adjacent, we have the opposite, we need tangent this time. Tangent of angle Q is equal to the opposite, 29, over the adjacent. Oh, I didn't say angle Q. Angle Q. That's the one I want to be looking for. Sorry about that. I could have said angle S, but if I want angle Q, we've got the opposite, we've got the adjacent. 29 divided by 18, so tangent of angle Q is equal to, so I don't have a calculator with me and I don't have the answer to this fraction written down. I'm going to estimate that that is about 1.6, and I really should put a couple of more decimal places down. And then if you go look up that in the table, make sure you're looking in the tangent column in the table. And if you're using your calculator, make sure you're doing tangent inverse to undo the tangent. Okay, we don't use a cosine inverse to undo a tangent. Okay, tangent inverse cancels out tangent, and the angle Q would be approximately equal to, and the calculator would tell you that that's going to come out to be about 58.2 degrees. And finally, this last one here. This one throws people sometimes the first time they see it, because we've got all three numbers, and suppose I want to find the measure of angle Z, and they'll ask me, well, which do I use, the sine or the cosine or the tangent? How do I know which one to use? Use any one at all. Regardless of which one you use, if you do it correctly, you should get the same answer every time. So use whatever one you're comfortable with. I already used cosine inverse over here. I used tangent inverse over here. So I'm just going to go ahead and use sine inverse over here. So sine of angle Z is equal to the opposite, 8, over the hypotenuse, 17. As a decimal, 8 over 17 is approximately 0.4706. And then you can go look up that decimal in the sine column of your table, find out what angle it came from, or do the sine inverse of the sine of angle Z, and the sine inverse of 0.4706. Sine inverse cancels out the sine and leaves the angle Z standing. And the calculator can tell you the sine inverse of 0.706 is approximately 28.1 degrees. Okay. So now we've got 4 problems at the bottom of this page, and some of them are like this new problem and some of them are not. I really urge you to do all of Target 3 version A to get the practice in, because when you keep changing from one problem to a different problem to a different problem, it's easy to get careless, to not pay attention, or to become confused. Here I've asked for the cosine of angle Q. Cosine of angle Q is adjacent over hypotenuse. Here's angle Q. The adjacent is 9. The hypotenuse is 41. I can't tell you how many students today I watched write this down. Cosine of angle Q is equal to 9 over 41. And then they did a lot more work, not realizing this is what I asked for in this problem. Cosine of angle Q equals what? And they wrote down, they literally wrote all of this down and didn't put a box around this and move on to the next problem. They decided they were going to look up this decimal value in the trig table and find the measure of angle Q. And they found it properly. Angle Q is approximately 78 degrees, but that is not what I asked for. I did not ask for the measure of angle Q. And so it was all wasted time, and they gave me an answer that wasn't incorrect, but an answer that I didn't ask for. You have to give me what I ask for. You have to give me what I ask for, otherwise I got to mark it wrong. Here, measure of angle A. All right, this is like the previous problems. Here's the opposite. Here's the adjacent. So the tangent is what I need. Tangent of angle A is equal to the opposite over the adjacent as a decimal value. 19 divided by 26 is approximately 0.7308. Now you take the tangent inverse of the tangent of angle A and the tangent inverse, or go look it up in the table if you want. Okay. Tangent inverse cancels out the tan, leaves the angle A standing, which is what I want, and the calculator can do that work for me. And really, I need the calculator to do that work for me. I have no way of getting a simplified value for that expression without the calculator's help. Unless, of course, I've got the table and I can go look it up at the table. Anyway, angle A turns out to be about 36.2 degrees. Again, if you're looking it up in the table, I would accept an answer of, excuse me, I kept most of that hidden. I think most of the time I was working on that. I apologize. If you were looking up this value, this decimal value, in the tangent column in your table, you should either give me an answer of 36 degrees or 37 degrees. Find the length of EG. Okay, that's the opposite. Here's the hypotenuse. I need sine. Sine of 41 degrees is equal to the opposite over the hypotenuse. Okay, so now I can go look up this in the table or put it in the calculator and get a decimal for that. Turns out to be 0.6561 equals x over 67. Multiply both sides by 67 to cancel out that division by 67. Put that in your calculator and we get a value for x of just about 44. If we round it to the nearest tenth, it actually comes out to be 44.0. And then the measure of angle F. Okay, we have the adjacent, we've got the hypotenuse. What connects adjacent and hypotenuse is cosine. Cosine of angle F equals the adjacent over the hypotenuse. Cosine angle F equals, put that in and get a decimal value out, and we got 0.9167. Okay, sorry about that again. 0.9167. And now, here's another mistake I see people make quite commonly. They'll now reach for their calculator and they'll put in their calculator, don't even write this down, this is so wrong, but they'll put in their calculator cosine of 0.9167. Nowhere in this equation have we written cosine of 0.9167. We have cosine of angle F. Over here we have a 0.9167 by itself. There's no cosine in front of it. So once again, how do we solve for that F? We have to undo that cosine. We got to get rid of that cosine. And the only way to get rid of a cosine is with a cosine inverse of the cosine of angle F. Taking the cosine inverse of the left side of the equation and the cosine inverse of the right side of the equation. Cancel, cancel. Angle F equals, put that in your calculator, you get a value for angle F of about 23.6 degrees. Okay. Do all the homework. It keeps jumping around from one problem to another to another. It's good practice. I urge you to do it. We got something new to learn tomorrow. Good luck.